Graph each function, find domain and range. The function is y equal minus 2 radical x minus 2 plus 1. Remember that these kind of questions, you can't only just watch the video and listen to the video and see the steps. You have to do it by yourself, to practice it. Okay? Otherwise, there will be some parts you miss it, okay? And you'll have problems or mistakes in the exam. So you have to practice it by yourself. Now, remember too, there are steps or basics, like basic points. Okay, we all agreed about that when we studied this chapter. Remember, we can start taking any general points, but belongs to the domain. Like we have x minus 2 under the radical. So x minus 2 should be greater than or equal to 0, which means that x should be greater than or equal to 2. Okay, so any point you take it here, for x, it should be 2 or more. You cannot take points less than 2. Why? Because when you replace it in the radical, you'll get negative. Radical negative is impossible, so you will not have values. Okay? So you remember that the domain of definition of this function is greater than 2. All x values greater than or equal to 2. Clear? Okay. Now, we have another way we studied when we graphed function. They said graph the function. So the main point is to have a clear graph, okay? Or approximately, okay, graph best fit of this function, okay? Now, let's go and see what we have to do. Let's graph the main function. You remember how do we graph the radical function, right? If we want to graph the parent function, radical x, okay? We said that we take the points which have radical gives you a natural number. Let's say 0. Radical 0 is 0. Radical 1 is 1. Radical 4 is 2. Radical 9 is 3. So, to avoid having decimals, okay, we choose these points, okay? So, in our function here, we have the parent function, radical x, but we have a translation 2 units to the right, and we have a translation 1 unit up, and we have also what? Vertical stretch, vertical stretching, because we multiplied by 2. So the main point here, let's graph the function with the parent, okay, with the vertical stretch, and then we do the translation manually on the graph. Then we get the graph representing this function. Let me show you how do we do this. As we agreed, for x and radical x, we have to take the points. In this way, there will be all questions you graph functions, you take 0, 1, 4, 9. That's the only point you need. Or even you can take 0, 1, 4. This is enough. So if we take the points 0, 1, 4, 9. If we make radical 0, what do you get? 0. Radical 1, 1. Radical 4, 2. Radical 9, 3. Now we look, leave that translation, the horizontal and the vertical. Let's multiply by minus 2. So if we multiply minus 2 radical x, let's multiply radical x by minus 2. Okay, we multiply all of these values by minus 2. Minus 2 times 0, 0. Minus 2 times 1, minus 2. Minus 2 times 2, minus 4. Minus 2 times 3, minus 6. So now we take these points, x, and this value, okay, these values, I'm sorry, okay, and we plot it on the graph, and then we do the translation minus 2 and plus 1 shown here, okay? Yeah, we have x equals 0, 0, 0. These are the points that we need. 0, 0. So this is the first point. Then 1 minus 2. We say this is 1 minus 1 minus 2. This is the second point. 4 minus 4. 1, 2, 3, 4. 1, 2, 3, 4. This is minus 4. This is the third point. And then 9 minus 6. So here is 9 and here is minus 6. Clear? Okay, now this is the function which is minus 2 radical x only. Okay, so let's graph it. Minus 2 radical x. This is the first one. This one is minus 2 radical x. Let's show it here. It's minus 2 radical x. Okay? Now, in our function here, we have a translation. How many units to the right? 2 units to the right. And how many translation up? 1 unit up. So, which means that, what do? We do every single point we did here, okay? We make translation. 2 units right, 1 unit up. Okay? Let's write it so that we don't forget it. 2 units right, 1 unit up. 2 units right, and 1 unit up. Okay? Or you can say 2 units right, 1 unit up. Just to remember. Let's go for each point, and let me change the color. Okay, so we do it in red. Okay, 2 units right, 1 unit up. We go over this point. 1, 2, 1. This is the first point. Yeah, let's go for the second point. 1, 2, 1. This is the third point. 1, 2, 1. And then the fourth point. 1, 2, 1. So we got new points. Then we join them with the same way we joined the first graph. And then we get the other function. So this would be the function that we want, which is minus 2 radical x minus 2 plus 1. Clear? So this would be easier. Now they are asking you for the domain and range. Domain and range, you can look at the graph and find it. Let's look at the domain. Look at the starting value for x. Started from where? From 2. And look at the function, the graph is to the right of 2. So the domain is, what do we say about the domain? Greater than, present domain is x greater than or equal to 2. What about the range? Okay, look at the range. The function is going down. So it's going down. Y-axis is covered. All of the y-axis below what? Below? 1. Yeah, look at that. It's at 1. And the graph of the function is under the 1. So the range is y smaller than or equal to 1. Okay? Clear? Now, with respect to the function with the 3 as an index, which is called cubic root. Okay, we have y equal to cubic root of x plus 1 minus 4. Okay, so this also comes from a parent function, which is radical x, but what's the index of the radical? It's 3, so we call it cubic root. Okay? But we have also vertical stretching, and we have translation here 1 unit left, and here we have 4 units downward. Okay? So if we start from the parent function, cubic root of x, remember that in the previous question, we had square root. We are not allowed to put inside negative numbers. But here, if we do cubic root of minus 8, it will be minus 2. So there will be an answer for radical negative. Also, cubic root of minus 1, cubic root of 0. So here, the best fit numbers, okay, gives you integer number without decimal, are minus 8, minus 1, 0, 1, 8. Remember, you can put more. You can put 27. Okay, you can put, let's say, 125, but they don't fit in the graph. Okay, so we need a bigger graph to graph these points. So the only points needed are minus 8. Okay, let me put it here. If we have x, this is radical x cube, cubic root. Okay, so we have, let's start from here. Minus 8, we can put minus 1, we can put 0, we can put 1, and we can put 8. So we can put more than these points, but we don't need it. Okay, so cubic root of x now. Cubic root of minus 8 is minus 2. Cubic root of minus 1 is minus 1. Cubic root of 0, 0. Cubic root of 1 is 1. Cubic root of 8 is 2. Okay, so always whatever is the function, but the cubic root start with the main one, which is cubic root of x, which is the parent function. Okay? And the next step, we multiply it by 2. We forget the translation. Forget the translation until the last step. Multiply by 2. So you get 2 cubic root of x. Okay? We multiply this cubic root of x by 2. So you get 2 times minus 2, minus 4. 2 times minus 1, minus 2. 2 times 0, 0. 2 times 1, 2. 2 times 2, 4. Now, we go to the graph and we locate the points. Minus 8, minus 4, minus 1, minus 2. So this vertical line, or like the vertical column, just we hide it. Okay, just hide it. We don't need it. Okay, we take this one and this one. This is x and this is y. Let's graph them on the graph. We have minus 8, minus 4. Let's go. Minus 8, minus 4. This is minus 4. That's the first point. We have minus 1, minus 2. Minus 1, minus 2. So this would be the point. We have 0, 0. That's 0, 0. We have 1, 2. This is 1. This is 2. And we have 8, 4. We have 8, 1, 2, 3, 4. So these are the 1, 2, 3, 4, 5 points we have. So join them smoothly, okay, and complete the graph. This is the graph of the function, which is part of the main one that we need. Okay, this would be the graph of the function 2 cubic root of x. Remember, here we have to do what also? We take different color and we do the translation. So how many units translation we have?
1 unit to the left.
1 unit left, so 1 unit. 1 unit left.
4 down.
And we have 4 units downward. Okay, so we go for any point we did here, all the points we did here, we take 1 unit left and 4 units down. So we do this. Take this point, 1 unit left and 4 units down. 1, 2, 3, 4. Okay, this would be the first point. We go for the second point, 1 unit left, 4 units down. 1, 2, 3, 4. This is the second point. We go for the 0. 1 unit left, 1, 2, 3, 4. This would be the third point. We go for the fourth one. 1 unit left, 1, 2, 3, 4. Okay, this is also another point. And here the last one, 1 unit left, 1, 2, 3, 4. Now look at the points, 1, 2, 3, 4, 5. Similarly, as we joined the previous graph, we join these. Do this, go and go up to this point, then move slightly to the left, and then this would be the graph. Look, it takes similar shape for the other one, but it is translated 1 unit left and 4 units down. Okay? Good.